Pre-Lab 7, Part 1. Jill of the Jungle swings on a vine, and I will let you read the rest. So she's swinging on this vine, which puts her in a path that is circular motion. You can see I've traced out part of a circle. And since this is circular motion, even though she's not moving the same speed the whole time, we can use the equations for circular motion to figure out the tension. So at this bottom of her swing, the rope is still 5 meters long, of course, and this will be our radius, because she is swinging about that point. We're given also the velocity and the mass. Here's a free body diagram. Tension is pulling up, and gravity is pulling downwards. I'm going to call upward the positive y direction. Since this is circular motion, F net is not going to be 0. You might think that the upward and downward forces are canceling perfectly, but actually, when we write out the F net equation, it will be gravity pointing downward. You can see at the bottom left of the screen, gravity points downward, that's why there's a negative, and tension points upward. This is equal to not 0, but mv squared over r, because anytime there is circular motion, the acceleration is centripetal acceleration, which is v squared over r. So before I do the uncertainty, I'm going to plug in numbers. You see I plugged them in, and this is 108 newtons plus 588 newtons, which equals 696 newtons. You know these are all newtons because I plugged in standard units, kilograms, meters per second, and so forth. So here's a little bit more information on centripetal acceleration. You'll soon see that v squared over r can also be written as r omega squared, because v equals r omega. That's just a preview for what you'll be seeing in class. Now to the uncertainty. Ft is, as we saw, mv squared over r plus mg. So you have to add the percent uncertainties for each of these terms, the mv squared over r term and the mg term. And then you will add the absolute uncertainties of each of these terms. So here are the absolute uncertainties given for m, v, and r. I found the percent uncertainties for each of those three values: 1.67% for m, 1.67% for v, and 0.2% for r. Then on the next page, you can see I calculated the percent uncertainty for this entire term, the mv squared over r term. That's what this subscript says, percent uncertainty first term. So you add up all the percent uncertainties, and then you have to convert back to an absolute uncertainty on this term. So this is 5.616 newtons is the absolute uncertainty for the first term. Now, you'll see I'm going to use that number in a moment. That's not the uncertainty on the final answer. You see, you have to get the percent uncertainty for the second term, which is mg. All of the uncertainty on this term comes from m, because g has no uncertainty associated with it. So, convert to percent, and then convert back to absolute, and you get 9.8 newtons is the absolute error on this second term. Finally, we have the absolute error on this first term and the absolute error on this second term. We add those two absolute errors that we just calculated independently. 5.616 newtons, which is the absolute error on this first term, plus 9.8 newtons, which is the absolute error on this second term. This gives you 15.4 newtons as the absolute error on the final answer. So your answer is 696 newtons plus or minus 15 newtons.